Okay, so in this video, what I'm going to do is that I'm going to be giving an introduction to the mensuration topic in mathematics. Mensuration topic. It's one of the topics in mathematics where you are going to find a lot of formulas. But before we come to the aspect of formulas, let us first try to give ourselves an introduction to the mensuration. So in this video, I'm going to be talking about the relationship that is there between three important things: the perimeter ratio, the area ratio, and the volume ratio. Volume ratio. So, the other name for the perimeter ratio, if you want, you can just call it the side ratio. The side ratio. And if we just observe them closely, you're going to see that anytime you're talking about perimeter, this is just more like the total distance around a given shape, right? You're going to see that normally this can be either in centimeters, meters, kilometers, in that aspect. If you're calculating the area of a given shape, look at the units. This is just going to be like centimeters squared, meters squared, kilometers squared. If it's the volume, it's three-dimensional. So it's going to be like centimeters cubed, meters cubed, kilometers cubed. I really want you to focus on the powers that these things are having. The centimeter is in the degree 1, meter degree 1, kilometer degree 1. The area ratio, centimeters squared, meters squared, kilometers squared. The volume ratio, centimeters cubed, meters cubed, kilometers cubed. This is very important if you're trying to establish the relationship that is there between the perimeter ratio, area ratio, and the volume ratio. So let us imagine maybe we have been given two similar cylinders. Two similar cylinders. How can we determine the area ratio and volume ratio? So let us imagine this is maybe 6 centimeters, maybe 9. And let us imagine maybe this guy to be 4 centimeters or 6 centimeters. This would be better. And then they just want us to determine the perimeter ratio or side ratio. Well, when you're determining the perimeter ratio, your perimeter ratio, which I'll just call your PR, when you're determining it, you can get either of these sides. This is 9 centimeters. It's a ratio. So 9 centimeters to 6 centimeters. The centimeters can easily cancel out each other. The centimeters can easily cancel out each other. So this and this will go. So what you're just going to have here is 9 to 6. But if you look at them, 9 and 6 are divisible by 3. So 3 into 9 then is just going to be 3. 3 into 6 then is just going to be 2. And that's it. This is how you can determine your perimeter ratio. Now, your perimeter ratio is the key here. In most cases, you cannot determine the area ratio and the volume ratio if you do not know your perimeter ratio or your side ratio. So how can we determine the area ratio now if we had such kind of a problem to solve? So I'll abbreviate our area ratio as AR. So your area ratio, notice the area ratio, when we were looking at the units for area, possible units, they were as like centimeters squared, meters squared, kilometers squared. There was that squared part, right? Squared, 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 squared. So your area ratio is just simply your perimeter ratio squared. Your area ratio is just simply your perimeter ratio squared. So how is this going to be done then? Your perimeter ratio had been determined to be 3 to 2. Squared. The power 2 can be distributed to each of these values. So you can have 3 squared to 2 squared, which is just going to be, 3 squared then is going to be 9. 2 squared then is just going to be 4. And that's it. That's your area ratio. If we were given a problem to determine our volume ratio, volume possible units, centimeters cubed, meters cubed, kilometers cubed. So your volume ratio, like I had said on the area, your volume ratio is just going to be your perimeter ratio to the power 3. So this is just going to be 3 to 2 to the power 3. You distribute the power 3 to both of these numbers there. 3 to the power 3, 2 to the power 3. 3 to the power 3, the answer is just going to be 27. 2 to the power 3, the answer is just going to be 9. And that's it. You have determined your volume ratio, your area ratio, and your perimeter ratio, just like that. So your area ratio is just the perimeter ratio squared. Your volume ratio is just the perimeter ratio raised to the power 3. Now, one thing that you also need to know is this one. These questions can be played around with. You might be given the area ratio, and you can be asked to determine the perimeter ratio. There are cases again whereby you can be given the volume ratio, and they want you to determine the perimeter ratio. So the other formulas that I want you to get, apart from this, and this one here, I want you to know that the perimeter ratio can also be expressed as the square root of the area ratio. And also, the perimeter ratio can be expressed as the cube root of the volume ratio. Because when we were moving from the perimeter ratio to the area ratio, we're introducing the square. So if we're going in reverse from the area ratio to the perimeter ratio, what we normally do is that we introduce the square root to the area ratio so that we can have the perimeter ratio. The square root of 9 is going to be 3. The square root of 4 is going to be 2. When we were moving from the perimeter ratio to the volume ratio, we were introducing the power 3, right? So this can also happen in reverse. From volume ratio to perimeter ratio, what I need to do now is that I need to introduce my cube root. If I introduced my cube, my power 3 here, then when determining the perimeter ratio, I need to introduce my cube root. So the cube root of 27 is going to be 3, because 3 times 3 times 3 is going to give me 27. The cube root of 9, let me just write this better. This should be 8. 2 to the power 3 is 8. The cube root of 8 is going to be certainly 2, because 2 times 2 times 2, the answer is going to be 8. So this is also something that you need to know. So try to get this as an introduction to the mensuration. So when you have been given a problem to calculate the area, maybe say the area of the big cylinder has been given, but you do not know the area of the small cylinder, what you should use here is the area ratio, because what you have been given is an area problem. What you have been given is the big cylinder, or maybe the small cylinder even, but you haven't been given the volume of the big cylinder. Because this question is now regarding volume, what you need to use is your volume ratio. But if you are trying to determine the sides, maybe say this is 9 centimeters, 6 centimeters, and maybe your radius value here has been given to before, and then you do not know the radius value of this small cylinder. I mean, it's a length value. So what you need to just use there is your perimeter ratio. So for problems regarding volume, use the volume ratio. For problems regarding the area, use the area ratio. For problems regarding how to calculate the length, how to find the length of a particular side, you should use the perimeter ratio in that case. So let this be an introduction to the mensuration. Thank you very much for watching.